Hi my dear friends, in this video we are going to see trigonometry exercise number 11.4 1 to 5 questions. So before going to solve these 1 to 5 questions, we have to learn one concept, trigonometric identities. Trigonometric identities. Okay. So we have three trigonometric identities, that is sin square theta plus cos square theta equal to 1, secant square theta minus tan square theta is equal to 1, cosec square theta minus cot square theta is equal to 1. So first you take one right angle triangle. ABC is the right angle triangle. Right angle at B. So now, if you see from A side, this is our opposite. So this is our adjacent. This is the hypotenuse. So now, we know that hypotenuse square is equal to opposite side square plus adjacent side square. So that is, hypotenuse is nothing but AC square, that is equal to, opposite is nothing but BC square, adjacent is nothing but AB square. So that is, you will get AC square is equal to BC square plus AB square. So now divide with AC square on both sides. If you divide with AC square, that is AC square by AC square, that is equal to BC square by BC square plus AB square by AC square. Left side we are dividing with AC square, as well as the right side we are dividing with AC square. AC square cancel, we will get 1. So in the right side, if we divide separately BC square with AC square, AB square with AC square. Now, you see here, we will write BC by AC whole square. This is nothing but AB by AC whole square. So what is the BC here in this triangle? BC is the opposite. What is the AC? Hypotenuse. Opposite by hypotenuse whole square. Next, AB is the adjacent, hypotenuse square. So we know that opposite by hypotenuse is nothing but side. This is nothing but sine A whole square. So this is nothing but adjacent by hypotenuse is nothing but cos. So that is sine square A plus cos square A. This is the trigonometric identity number 1. That is sin square theta plus cos square theta equal to 1 or sin square a plus cos square a is equal to 1. So this we are going to use in our upcoming problems. So we should remember this identity. Sin square a plus cos square a is equal to 1 or sin square theta plus cos square theta is equal to 1. So that is the first identity we got. Sin square theta plus cos square theta is equal to 1. From this we can write two more sub-identities, that is cos square theta is equal to 1 minus sin square theta. Sin square theta is nothing but 1 minus cos square theta. So cos square theta means if you send sin square theta to right side, 1 minus sin square theta. Sin square theta means if you send cos square theta right side means 1 minus cos square theta. So now if you divide with BC square on both sides, that is AC square divided with BC square. BC square by BC square and AB square by BC square. So now you see this is nothing but AC by BC whole square. This is nothing but 1. This is nothing but AB by BC whole square. In the triangle, what is AB by BC? What is AC by BC? AC is nothing but hypotenuse. AC is nothing but hypotenuse. BC is nothing but opposite. One. Next, AB is nothing but the adjacent. BC is nothing but opposite. So hypotenuse by opposite is nothing but cosec A whole square. 1 plus adjacent by opposite is nothing but cot. So that is cosec square A 1 plus cot square A. If we bring this one to left side, cosec square A minus cot square A is equal to 1. This is the identity number 2. Cosec square A, that is cosec square theta minus cot square theta is equal to 1. Cosec square theta minus cot square theta is equal to 1. Cosec square A minus cot square A is equal to 1. This is the identity number 2. Next, one more identity. We have 3 identities. Now, if you divide with AB square on both sides, that is AC square by AB square, BC square by AB square, AB square by AB square. So this is AC by AB whole square, BC by AB whole square, AB square by AB square. That is nothing but 1. Both gets cancelled, we will get 1. So now from this triangle, AC is nothing but the hypotenuse, AB is nothing but the adjacent, square is there, BC is nothing but opposite, AB is nothing but adjacent, square. So hypotenuse by adjacent. Hypotenuse by adjacent is nothing but secant. Secant A whole square. Opposite by adjacent is nothing but tan. Tan A whole square. Okay, now this is nothing but secant square A. This is nothing but tan square A. Now bring tan to left side. Tan square A. So this is the identity number 3. Secant square A minus tan square A is equal to 1. That is nothing but secant square theta minus tan square theta is equal to 1. So we are going to use these 3 identities to solve these problems. Okay, now we will see one by one question. Okay, now we'll see the question number 1. That is 1 plus tan theta plus secant theta into 1 plus cot theta minus cosecant theta. Now, just you see, 1 plus tan theta is nothing but sin theta by cos theta. Tan theta is nothing but sin theta by cos theta. Secant theta is nothing but 1 by cos theta. 1 by cos theta. Secant and cos are reciprocals to each other. Sin and cosec are reciprocals to each other. Tan and cot are reciprocals to each other. Cot is nothing but cos by sin theta. Cosec is nothing but 1 by sin theta. Okay, now first what you do, tan theta means you write as a sin by cos. Secant means 1 by cos. Cot means cos by sin. Cosec means 1 by sin. So after that, take the LCM. So here the LCM is cos theta. So now here cos theta is not there. We should multiply and divide with cos theta. So that is cos theta plus sin theta plus 1. Next here also we take the LCM, that is sin theta. Now multiply and divide with the sin, you will get sin theta plus cos theta minus 1. Now, so finally we are getting, just rewrite sin theta plus cos theta plus 1 by cos theta. Here sin theta plus cos theta minus 1 by sin theta. Now you observe this. So it is looking like A plus B, A minus B. A plus B into A minus B. A plus B into A minus B is nothing but A square minus B square. Similarly, we will apply the same concept. Sin theta plus cos theta whole square minus 1 square. In the denominator, cos theta into sin theta is nothing but cos theta into sin theta. So we know the formula of a plus b whole square, a square plus b square plus 2ab. So now this is the formula of a plus b into a minus b. Next, a plus b whole square, that is nothing but a square plus 2ab plus b square. So now a square is nothing but sin square theta 2ab, 2 into sin into cos. B square is nothing but cos square theta minus 1 by cos theta into sin theta. So now you see sin square theta plus cos square theta. You write these two together. After that you write 2 into sin theta cos theta minus 1 by cos theta into sin theta. So now you see, observe these two. Sin square theta plus cos square theta is equal to 1. We have an identity. So now you substitute in the place of sin square theta plus cos square theta, that is 1 plus 2 times sin theta into cos theta minus 1 by cos theta into sin theta. So plus 1 minus 1 cancel. So we left with 2 times sin theta into cos theta by cos theta into sin theta. Cos, sin both gets cancelled. The answer is 2. The answer is 2. Just check once again. Okay, now we will solve question number 2. Okay, now question number 2. What is the question number 2? Sin theta plus cos theta whole square plus sin theta minus cos theta whole square. So it is looking like a plus b whole square. It is looking like a minus b whole square. So the formula of a plus b whole square is nothing but a square plus 2ab plus b square. A minus b whole square is nothing but a square minus 2ab plus b square. We use these two formulas to solve this question. So now sin theta plus cos theta whole square, a value is nothing but sin theta, b value is nothing but cos theta. So now first a square, that is sin theta square, a square, 2ab, 2 into a value sin, b value cos, plus cos theta whole square, plus second one sin theta whole square minus 2ab, 2 into sin into cos, last again cos theta whole square. This is nothing but b square. So now this is, you see, sin square theta plus 2 times sin theta into cos theta. This is cos square theta. Next, plus sin square theta minus 2 times sin theta into cos theta. Again cos square theta we are getting. So just you see, write these two sin square theta plus cos square theta together. Again these two sin square theta cos square theta together. So this is 2 times sin theta cos theta, 2 times sin theta cos theta gets cancelled. One is plus, one is minus. So we left with finally 2 times sin square theta, 2 times cos square theta we left. So take 2 common. Inside sin square theta plus cos square theta will be there. If you take 2 common. So we know that sin square theta plus cos square theta equal to 1. Substitute that value. 2 into 1 become 2. 2 into 1 become 2. So this is the way we have to solve the given question. Just check for 1 minute. Next question number 3. Question number 3. Okay. Question number 3 is nothing but secant square theta minus 1 into cosecant square theta minus 1. So we have two identities. One is related to secant square theta, one is related to cosec square theta. So that is, we have identity like this. Secant square theta minus tan square theta, that is equal to 1. So from this, if you bring 1 to left side, take this one tan square to right side, secant square theta minus 1 is equal to tan square theta. So similarly we have cosec square theta minus cot square theta is equal to 1. So now if you bring 1 to left side, take this cot to right side, cosec square theta minus 1 is equal to cot square theta. So now we can replace in the place of secant square theta minus 1 is equal to tan square theta. This is nothing but tan square theta into cosec square theta minus 1 is nothing but cot square theta. So tan is nothing but 1 by cot square theta into cot square theta. Both gets cancelled. That will give you 1. So this is the answer for the given question. Secant square theta minus 1 into cosec square theta minus 1 is nothing but 1. Next question number 2. Next. So show that cosec theta minus cot theta whole square is equal to 1 minus cos theta by 1 plus cos theta. So he was asking to show that cosec theta minus cot theta whole square is equal to 1 minus cos theta by 1 plus cos theta. So now what we have to do? First take the left hand side LHS. So that is cosec theta minus cot theta whole square. So first you see cosec theta is nothing but 1 by sin theta. 1 by sin theta. Cot theta is nothing but cos theta by sin theta whole square. Now you see, so sin theta is the same for both the denominator. So directly we can subtract the numerators. So now you write separately for numerator and separately for denominator. Now you see, in the denominator it is nothing but sin square theta. So now we have an identity, that is sin square theta plus cos square theta equal to 1. From this we can write sin square theta is nothing but 1 minus cos square theta. So replace that sin square theta value with 1 minus cos square theta. So that is 1 minus cos theta whole square by sin square is nothing but 1 minus cos square theta. So now you see here. So what we left? 1 minus cos theta whole square, and we left with 1 minus cos square theta. Right here a square. It's look like a square minus b square. A plus b into a minus b. Here in the numerator, a square can be written as a into a. In the denominator, a square minus b square can be written as a plus b into a minus b. A plus b into a minus b. So numerator is looking like a square. Denominator is looking like a square minus b square. So a square is nothing but a into a. So 1 minus cos theta into 1 minus cos theta. In the denominator, a square minus b square we are applying, that is a plus b into a minus b. 1 plus cos theta into 1 minus cos theta. Here a value is nothing but 1, b value is nothing but cos theta. So now you see both gets cancelled, 1 minus cos theta by 1 minus cos theta. So finally we left with 1 minus cos theta by 1 plus cos theta. So this is the RHS he was asking to prove. So therefore finally we get it, LHS is equal to RHS, hence proved. So next question number 3 is a very important question. So expecting for 4 marks question number 3. So this is show that secant A plus tan A. So to prove that, first you take the left hand side value, that is LHS. What is the left hand side? Under root of 1 plus sin A by 1 minus sin A. So to prove this, first what we have to do, rationalize the denominator. So to rationalize the denominator, so we should multiply the denominator and numerator with rationalizing factor. So 1 minus sin A is there in the denominator. So rationalizing factor will be 1 plus sin A. So this is a rationalizing factor. So now we are multiplying and dividing the denominator and numerator with 1 plus sin A into 1 plus sin A. Now you see in the denominator it is looking like a minus b into a plus b. That is nothing but a square minus b square. We will apply that formula. Numerator is looking like a into a. Numerator is looking like a into a. That is nothing but a square. Denominator is looking like a minus b into a plus b. A square minus b square. So 1 plus sin A whole square is the numerator part. Denominator is nothing but a square minus b square. That is under root of 1 plus sin A whole square by 1 minus sin square A. So we know that sin square theta plus cos square theta is equal to 1. From that we can derive, if you bring 1 to left side, take this sin square to right side, that is cos square theta is equal to 1 minus sin square theta. So 1 minus sin square theta can be written as a cos square theta. that is 1 plus sine A whole square. This is numerator is same as it is. Just we are changing the denominator like this. 1 minus sine square A is nothing but cos square A. Cos square A. Square and root gets cancelled. Square and root gets cancelled. Finally, we left with 1 plus sine A by cos A. Write separately 1 by cos A, sine A by cos A. So 1 by cos A is nothing but secant A. Sine A by cos A is nothing but tan A. So this is the required RHS. LHS is equal to RHS. Hence proved. So this is the way we have to solve this question. Just check. This is an important question for 4 marks. So share these videos to maximum number of students of 10th class. So you can keep it in your status. So try to keep these video links in your WhatsApp status, Facebook, Instagram, so that it will reach to more number of students. They will get the benefit of it. So question number 4. Show that 1 minus tan square A by cot square A minus 1 is equal to tan square A. He was asking to show that 1 minus tan square A by cot square A minus 1 is equal to tan square A. So now first we will take LHS. Similarly what we did in the previous one. Take the left hand side. 1 minus tan square A by cot square A minus 1. We know that tan is nothing but sine by cos. So that is sine square A by cos square A. Cot is nothing but cos square A by sine square A minus 1. So here take the LCM, here also take the LCM. So we will a numerator, that is cos square A minus sine square A by cos square A divided by cos square A minus sine square A by sine square A we are getting. So fraction by fraction, if the denominator is fraction is going to numerator, so this is a fraction 1, this is a fraction 2. If this fraction is going to numerator, it will become reverse. So cos square A minus sine square A by cos square A into sine square A by cos square A minus sine square A. Okay, now these two gets cancelled. Finally, we left with sine square A by cos square A. It is nothing but tan square A. This is RHS. LHS is equal to RHS, hence prove. So another way also we can solve this problem. Just we will see that method also. See here. 1 minus tan is nothing but 1 by cot. Right? Cot square A by cot square A minus 1. So now take the LCM in the numerator part. That will give you cot square A minus 1 by cot square A. By we have cot square A minus 1 in the denominator. So this is a fraction number 1. This is a fraction number 2. So if the denominator's fraction is going to numerator, it becomes reverse. So that is cot square A minus 1 by cot square A. This is a numerator fraction. So now this is going to numerator, it becomes reverse. 1 by cot square A minus 1. So both gets cancelled. We left with 1 by cot square A. That is nothing but tan square A. So this is the way also we can prove. LHS is equal to RHS. Next, fifth question. So with this, we are completing this session. So we will see the most important problems 6 to 10 in the next video. So that is 1 by cos theta. This also show that minus cos theta is equal to tan theta into sin theta. So take the LHS similarly. That is 1 by cos theta minus cos theta. So now here you take the LCM. Cos theta is our LCM. 1 minus cos square theta you will get. So we have an identity. Sin square theta plus cos square theta is equal to 1. That is, if cos square theta is going to right side, that is sin square theta is equal to 1 minus cos square theta. So in the place of 1 minus cos square theta, we can write sin square theta. Sin square theta by cos theta. So sin square is nothing but sin theta into sin theta by cos theta. So we can write this sin theta by cos theta into sin theta. Sin theta by cos theta is nothing but tan theta into sin theta. So this is the RHS. Hence, prove LHS is nothing but RHS. LHS is equal to RHS. So this is the way we have to solve the problems of exercise number 11.4. In the next session, we will see the problems 6 to 10.